So today we're going to talk about dependency injection. And my name is Vadim Trifonov. I'm leading iOS development in Swedbank. So my background is heavily in mobile engineering, so certain examples here in this talk will be definitely from mobile apps. So before we will start, I would assume that most of you are familiar with dependency injection concept, but let's have a quick show of hands. How many of you find it still somewhat confusing or not that clear where the dependency injection starts and ends and what the concept is all about? Okay, quite a number of hands, but most still find they understand. Both answers are great because I have, for both parties I have something. So now quick show of hands, who uses some kind of library or framework for dependency injection? So most are using some libraries. And who are using their own implementation, like without any frameworks? Yeah, we have at least one person. So one person can relate, others might be interested. So yeah, read it. First, let me bring you up to the concept of dependency injection in layman terms. So if some of you would like to explain the dependency injection idea to someone else who is not a technical person, so you can approach it this way. Like imagine 5-year-old kids and imagine that they need to have some kind of a meal, something to eat. So would it be a good idea for them to somehow find this or prepare this meal themselves? Hit the fridge, go shopping to the grocery store? Probably not. You don't want your 5-year-old kids or any 5-year-old kids going around and trying to prepare their meal on their own. So what the citation says is that it would be better for them to state their need, to say what they want. Maybe they can express what kind of a dish they want, but someone else, preferably their parent or some third party, will resolve this need for them, will provide what they need. So this is like the most fundamental or basic idea behind the dependency injection. Someone else provides you what you need. So then probably the next question or like the question based on the title is why pure? What the pure means. So the pure meaning that not using any kind of library, not using any kind of framework. Well, dependency injection is not about frameworks. It's not a container, it's not your Spring, it's a library, it's not any other framework, or Unity if you're from .NET or Dagger or anything like that. So first and foremost, it's a bunch of principles and patterns, and that's it. So you can implement any kind of dependency, you can implement dependency injection with patterns and principles. You don't have to rely on frameworks. And there are primarily two reasons why you would want to do that. So first is a really easy one. We see no shortage of languages appearing which have no established communities or code base or decade-old code open source libraries like Java or .NET have. So with languages like Swift, Rust, Go, Dart, Solidity nowadays, we still end up figuring out on our own what we should do about dependency injection. Whether we inject anything at all or we end up doing something else. And the second reason is that maybe for some reason you don't want or you don't like invasive dependencies. So frameworks like Spring, especially Spring like Juice and their counterparts in .NET, they're quite invasive. So depending on certain circumstances, you might not want to have @inject annotations or something like that. Of course, in Java nowadays, as far as I know, it's sort of already almost on a language level provided to you. So it's like less of a choice or a problem. But in many languages, you still might not want this dependency. or on the third-party framework. So if you can relate to the second opinion, well, you're not alone. Actually, Uncle Bob wrote in one of his blog posts that he doesn't want his code to be riddled with @inject annotations, and he wants to keep the frameworks at hand's length from his code. And there are certain circumstances where it's useful. For example, you're rapidly prototyping something, or you're not sure with what framework to go, or you're building your own small application, or, as we said, the language simply doesn't have any kind of good libraries. So you can sort of use patterns and principles that I will show you and have dependency injection advantages or benefits with you. So we will have two parts. First part is quite, I wouldn't say easy, but it's about fundamentals. So many of you are familiar with what I will tell. And the second part is rather complex. But I've tried to, as much as possible, to explain it clearly. And it will be about lifetime management. But let's figure out fundamentals. So if you feel you're new to dependency injection or not, you find it confusing, this is what you need to know to remove this confusion. And this is like where you start from. So we can say that there are mainly three obstacles in understanding and having dependency injection in your code. And I will show you three techniques how to avoid those obstacles or how to handle those obstacles. And each technique will be structured the following way. I will set the context. I will show you the problem which appears in this context. I will show you or explain the insight, how you approach solving this problem. And I will provide you with active argument, what you should be actually doing. So technique one is the most important, and it's about like the most basic idea of dependency injection. And I want to preface it with this quote. So probably some of you have already heard about or read somewhere that dependency injection is kind of like a $25 term for 5-cent concept. Of course, it's a bit of understatement. They're trying to underplay the complexity, but it's definitely about the first technique. It's definitely about the main idea of dependency injection. So let's set the context and see where we will find this idea. So you have two classes, a standard situation. One depends on another. In my case, it would be, for example, some kind of a controller and some kind of application service. Controller, think not the some framework controller, your own controller, like interactor maybe. And you will quickly, if you're doing this for the first time, you will quickly stumble upon a first problem, maybe momentarily, but you have to ask something from the service. And the question is, where does the service come from? Well, the most natural or like the straightforward solution to this is just simply to instantiate it, inline it here, where I have a comment. Well, most of you probably, I guess, know that this is not a great option, but why? Well, because you don't want to be tightly coupled. As soon as you would initialize service here, you have to know the particular implementation of the service, and you know a lot. You depend on this particular implementation. You know more than probably you should about this particular implementation because you have access to particular implementation. And you definitely now imported the framework or the module or the component where this dependency lies. And we have a virtue in software engineering called being loosely coupled, loose coupling. So when you are not relying on any particular instance, but relying on an abstraction, well, you're approaching being loosely coupled. And being loosely coupled gives you a lot of advantages. First and foremost, it's dynamic dispatch. If you don't know what kind of instance you're asking to do something, it can be dynamically picked for you at runtime. You have extensibility. For example, you can pass a decorator. You can decorate the service you want with a number of decorators which would implement some kind of aspects, logging, cross-cutting concerns. You can have parallel development. Well, I decided that I need this abstraction. If you know about clean architecture, I decided, for example, that it needs to do this and that, and someone else will implement it. There is a maintainability. Well, loosely coupled code is basically the essence of being maintainable. And testability. Well, it's easy to sort of put stops all around your code or object of interest and test it in isolation. So once we know that being loosely coupled is a good idea and we don't want to be tightly coupled, we need an insight how to solve this. And the insight here is that someone else, like the 5-year-old kids, should provide this instance to you. So in our case, it's an infrastructure, something who runs or calls your controller. And my active argument, for provision, you should use constructor injection. This is the most natural way. And from object-oriented perspective, the most clean way. So the simple constructor in language Swift will look like this. This is Swift. There is nothing special about the syntax, or I would not use anything special from the language itself, so it should be quite recognizable as any other object-oriented programming language like Java or C# or anything like that. So it's easy. We provide service to the constructor and we store it. And by the way, if you're using constructor injections for that, remember that your injection constructors should be really simple. They shouldn't be doing any kind of work. Their idea of them is to store the dependencies they're provided. Because when you're building a complex object graph, you don't want to be doing anything at the same time. So once we figured out the technique number one, and by the way, this 5-cent concept, providing dependency through the construction, let's see what our next stumbling block will be. Well, when you have now a number of classes, everyone wants to be initialized with their dependency. Naturally, the question is, who is responsible for all those initializations? It's not me. It's not login router, someone else. So taking to the extremes the previous argument about or insight about the infrastructure, we can apply it here as well. Again, someone higher on the call stack is responsible for this. And the argument is that it's a notion of composition root, or concept of composition root. So the composition root, in words of Mark Simon, who wrote a terrific book on dependency injection called Dependency Injection in .NET, he said that the composition root is preferably a unique location in your app where you assemble your application from separate modules. And to provide you with an example, for example, in iOS apps, if you're familiar with them, the composition root would be your entry point to the application. And the first entry point to application is application did finish launching with options of app delegate class. For Android applications, it's onCreate method. For console apps, it's naturally your main method. And for Windows apps, it's app.xaml, at least to my knowledge. Now, the really simple composition root would look like this. It's a simple main function which takes some arguments, and you construct your object graph here. You initialize everything if you can, and you start doing something. Put things in motion. So in this case, it's really simple. We initialized authentication surface, passed it to the login controller, thus resolving the login controller, passed the controller to the login router, thus resolving the router, and started the router. The really simple composition object graph. So once you solve this obstacle, there is one left. At some point, you will face the following issue. Now, you have a certain dependency, and it depends on the runtime value. So you cannot resolve it beforehand. You don't know this runtime value at compile time. So in this case, our account service tries to use some kind of authorized client. And the authorized client depends on the session token. And the session token is quite obviously something which we receive after logging in. So what to do about this? Our authorized client might look like this, which depends on this runtime value. It requires session token in its initializer. So we need a new insight here. So the insight would be quite similar. Again, we want to delegate this to infrastructure. We want someone else to care. But the infrastructure in this case now should promise us that given the runtime value at a certain point, it will return us the instance we're looking for. And what lies behind is a concept of, or the pattern abstract factory. And what's interesting about abstract factory in this case is that it's a double abstraction. Abstract factory is an abstraction on its own, which promises us the abstraction we're looking for. Meaning that it can be easily stopped to return stopped instances if we are trying to test something. So the abstract factory in Swift would look, or definition for that, would look like this. The protocol, you can think of it as an interface in Java or .NET. And it says that it will make us the client given the session token. Implementation is also rather simple. Given the session token at runtime, it will instantiate the authorized client. So this is sort of like a promise. We can pass this promise to our account service. Account service will use this promise and will resolve the client it needs. And if you're lucky ones who have first-tier functions in their language, like in Swift, we can simply state that, in this case, abstract factory is simply a function, pure function, which will take some argument and return the client we need. And it can be implemented like this. So let's see in action. We have a login router. Login router needs its client to do something, given the session token. Once we acquire the session token at runtime, we pass it to the factory. Factory creates us the proper client, and we can continue. So this wrap-ups 3 techniques. And it's enough, actually, to roll your own dependency injection. And it's definitely enough for simple projects and your own prototypes, and not very complex applications. So you only have to know about constructor injection and use it. You should compose your object graphs or instantiate everything in the composition route. And things that you cannot instantiate, well, provide factories for resolving at runtime. But, well, certain apps are quite complex. So we have to talk about the lifetime management. Well, so far we avoided somehow, or more or less, the lifetime management issue. And lifetime management is essentially how long something lives, how long it should live. And one of the important concepts regarding lifetime management is called scope. Essentially, the scope is how long or how many method calls certain object lives. And as long as object lives, we say that it's, for example, in a certain scope. And probably, if you're using frameworks, you should be familiar with the idea of scope. And usually, frameworks provide you with usually four scopes. It's no scope, or called usually prototype. It's your singleton scope or global scope. It's your session scope and request scope. But let thread scope. Okay. As long as your thread lives. Good. So let's take a closer look at what the no scope is all about. So in order to understand the no scope, think of two persons, Jack and Jill, arriving at campsite, and then they need, for their stay, they need to brush their teeth. And they should be provided with a toothpaste. So every time they need to brush their teeth, they are provided with toothpaste. Basically, the toothpaste initialized for them and provided. So next time they need to brush their teeth, then again, the toothpaste is provided to them. And so it goes. So basically, every time they need to brush their teeth, a new toothpaste is provided. There is no scope. Toothpaste is immediately discarded once it's no longer used. And it's kind of wasteful. The next scope, quite popular one, global or singleton. You can imagine, like, if Jack and Jill would have been provided with a single toothpaste, both are using the same toothpaste. And the problem of this is quite obvious. For the whole stay, both of them will be using or sharing this same toothpaste, and you can expect certain collisions. For example, Jack is really wasteful, and Jill is really mad about this. So he used much more toothpaste than she did, and she's kind of now pissed off. And the toothpaste ran out. And behavior of, in this case, the state and behavior of the toothpaste was unpredictable for both parties. Not ideal situation, but we quite often encounter this in our apps because of the stale state or the shared state. What we need to solve this issue in this particular case is some kind of a custom scope. Think of a bathroom. Let's imagine that both are provided some camp booth on the campsite. Where is the bathroom? And the toothpaste now lives in this bathroom. So both Jack and Jill go to the scope of this bathroom, find their own toothpaste there every time, and quite happy because no one else uses it. The toothpaste won't disappear, it will live in the bathroom for the whole stay. So this is the idea of creating your own custom scope or defining custom scope or finding custom scope you need for your application. And the question is where those custom scopes are useful. So if you will go back to the request, for example, scope and the session scope applicable for server applications, these are kind of quite defined or predefined for you, which is nice because historically we define that certain things should live as long as the request lives, and usually it's very short, it's short-lived because request arrives, you want to process it as fast as possible and return something and deinitialize everything you initialized for this processing. With session scope it's a bit trickier, and if I'm not mistaken, nowadays usually we prefer to avoid the session scope and being stateless as much as possible. But in this case, it's naturally something lives as long as the session lives on the server. But in case, for example, interactive apps and mainly UI-driven apps, like desktop apps, front-end apps, mobile apps, you need deep scopes. You need custom scopes, which will be quite nested. And I want to show you an example of how it will look like to have custom scopes. So let's define the first scope, which is first one is really natural. It's root scope. It's your entry point application. It's where everything else, from where everything starts. Now let's say the next scope would be session. And by the way, this example is taken from our actual app under development. It's a very small portion of it, but it's based on how we do things for production. So the session here, the idea of session is that it's a certain scope which observes the presence or absence of the session. And to make it easier to you to understand what those root and session on the screen are, think of them as routers. You can imagine it as being a router. It's not a router from any kind of framework. Just think of it as, think of this, the small part of the tree you see, think of it as a top level object in this node. It's essentially something which represents the node in the tree and retains everyone else who are alive at this node. So router is responsible for, well, in this case, root router is responsible for attaching the session router when the application starts. And it's really simple. It just creates the session router when the time came and starts. The rest of the details are not important. So now let's go back to the tree. Let's make the actual tree. So as I said, session sort of observes what is happening in the system, and depending on whether we have session in the system or not, attaches another scope. Since we have no session, it attaches the logged out scope. Logged out scope attaches the welcome screen or the welcome scope, and the welcome screen presents the possibility to do the login. So once you press the login button, for example, the login will be attached. When you've successfully logged in, the session appears in the system. The session scope, by observing the appearance of the session in the system, or the session parameters, will detach the whole part of the tree because it's no longer needed, essentially deinitializing every dependencies, and will attach the new scope called logged in, and will pass our session parameters there. The logged in will attach the customer scope, which is responsible for deciding which functionality is available. And as a remark, I should say that the customer notion here is from our banking apps. And it means that, for example, you as a user might have access to a certain number of customers. Your own customer, your wife's customer, your children's customers. So depending on the selected customer, you might have different functionality available to you. And the customer, in our case, attaches the account balance. Okay. So we have this scope hierarchy. And let's see, and by the way, before we'll see, if some of you are familiar with mobile development, only the scopes in blue are actually presenting something on the screen. The rest here are to have this hierarchy of use cases. So let's see what kind of dependencies might exist at certain scopes. So the root scope naturally creates and retains the dependency of your initial configuration of your app. Session scope creates and responsible for keeping alive the session store because it's actively monitoring what's happening, whether the session appearing, disappearing. But if you remember, when we logged in, the session token was passed, or the session parameters, and now logged in is able to create an authorized client. Because there is no guarantee that the authorized client will work because we have the required session token. Customer is responsible for observing the customer store, and then you can see what kind of customers are selected. And the balance wants account service. This is what balance uses to retrieve the accounts and their balance. So, if you're still with me, now will come the hard part. Because let's take a closer look what we have. So the balance wants account service, which depends on authorized client. And we know that authorized client can be initialized only with session token, meaning it depends on runtime value. We can make two observations here. First is that authorized client can be initialized only at runtime, meaning that we cannot pre-initialize it at compile time. Of course we could, but then we would have to make runtime checks whether we have session token or not. And if we don't, it's kind of exceptional state. We don't want this. We have this deep scope, beautiful deep scope hierarchy to avoid these kind of issues in principle. And the second observation is that customer node kind of has no dependency on authorized client because, well, customers were loaded when you've logged in, and they are only stored there. So the customer scope doesn't use the authorized client to download anything. It just observes the change selected customer in the customer store. So there is no natural need for the customer to know about anything authorized client. But the balance wants to know. And the problem here is that, well, how can we resolve account service in this situation? Well, what we can do is to take this authorized client, pass it to the customer scope or customer router when we're initializing it. For example, it can be as a parameter to this factory function. Pass it down the scope. Well, customer now sort of depends on authorized client. It definitely knows about the authorized client. It sort of stores it. And when the time comes, the customer will create the balance and will pass the authorized client. Balance will use the authorized client to resolve the account service, essentially passing it to the factory method of the method which resolves the account service given the authorized client. It kind of works. There is nothing like immediately wrong with that. We kind of have a problem here. Authorized client became a pass-through dependency. So, but we don't want that. This is not a good idea. Because in this case, the tree is really simple, quite trivial. We have only one node in between. But imagine like 5 or 6 nodes, and imagine that the bottom node needs something from some dependency which exists on the top node, the top scope. Would it be a good idea to pass the dependency all along the tree downwards? No, not really. You would do a lot of busy work for that. And you would expose a lot of unneeded information to the scopes which don't want to know about this. So let's go back to the drawing board here and see what we know about scopes, or what scopes promised us. Well, child scope, in this case balance, should have access to all parent dependencies. And that means that it should have access to customer dependencies naturally, somehow should be able to inherit locked-in dependencies, somehow be able to inherit the session dependencies, and somehow inherit root dependencies. We don't know exactly how at this point, but it's a logical assumption. This is why we have scopes in the first place. We know that as long as a customer or locked-in leaves, their dependencies are available to us naturally, or should be available. And we want one more thing. We want fully static compile time guarantee that this resolving will succeed, meaning no runtime trickery, no any kind of sort of service location thing where you ask and hope that it will be there, or other crash or null pointer exception or anything like, or something like this. No, we want guarantees. So if it compiles, it will be resolved successfully. And if you're familiar with, by the way, quick show of hands, who are familiar with Dagger2 framework? Okay, one hand. This is, 2 hands, sorry. I haven't counted my friends. So for you, you should be familiar now with idea of what the Dagger2 promises. It promises the same thing. It's fully static compile time guarantee because it analyzes your graph, your application graph at compile time. And we want the same thing. So how we will achieve that? Let's introduce a new abstraction. The component here name is, don't think about it. Think of it as a dependencies provider. something along the lines. The essential thing is that this is abstraction where we declare all the dependencies we need for this root node. And it's only abstraction. We don't know who will be resolving or how these dependencies, but we know that we want this abstraction given to us, and we will take our dependencies from there. The component name was borrowed from the Dagger 2 framework, so don't think that much of it. No. The important thing is that component will be responsible for creating its subcomponent, naturally. And now we have a whole tree of these component abstractions. So for every node, we defined an abstraction which sort of declares all the dependencies we need for this node. The interesting thing here is that the actual implementations of these abstractions, of those interfaces, let's say, will live not in the same physical place where they're declared. So we can imagine, like for root, for example, and root component are declared in the same module, physical component. But I won't use the word component, not to confuse you. I will call it module. Think it as like kind of maybe library or something like that, whatever your language supports. So some boundary. And the white part here is where you assemble things. Is where you compose those objects in some coherent application. Remember the composition root? So think of those. The black side is a bunch of Lego blocks or modules, and the white side is where you put those modules together and you have an app. And this is where you will be resolving dependencies. The interesting thing, we implemented these interfaces. Now we have to resolve dependencies. How we will be doing this? Well, the things which are, we know that we should be initialized first because no one else initialized it before, because we are the first scope where this thing lives or appears. We will just simply initialize it in this implementation. But the things we cannot initialize, we will have to rely on our parent. And if you can see it, we have kind of, sort of, I want to use the word tricky, but it's not about trickiness. But it's a tricky inversion. Our abstractions know nothing about their parents. We keep the sanity. Our parent knows about its child doesn't know anything about the parent. But implementations, the nitty-gritty details, they can know about parent. It's only assembly, or meaning that assembling the app, putting things together, that's very few code. So what it gives us? Let's first take a look at this part. Let's see how it will look like in code. Otherwise, it might feel a bit too abstract. So let's see how session router relates to its declared dependencies. We have the session router. What's important about session router is you can see that it has, for our interest, for our purposes, it has one component, its own component. And it asks from this component this make logged in component, the subcomponent. And given it, provides a session token where and it's able to create logged in router. So the abstraction of this component looks like this. It declares that it will provide the session store for this session router and a way to create a logged-in component, essentially a factory method. And it's really simple. We have router and what we need for this router to function. After the session, we have logged in, and we have the same thing here. Logged in also has its own component. It uses the component to create the subcomponent and attach the child node. And its component is even more trivial. It just declared that it's able to create a subcomponent. So we've seen that the session session router, how its session component abstraction looks like, and how the locked-in router looks like, and its locked-in abstraction, dependency resolver abstraction. What's more interesting, let's now see how the actual implementations look like of those components. This is our, we've seen it already, session component abstraction. It still declares the session store, still provides the way to build the subcomponent, which is logged-in component. This is how you would implement it in the composition group, where you assemble things. Well, the session store is easy. We're the first to use it. If we live in our scope, we will simply instantiate it. And in order to create this factory method here, we will instantiate the locked-in component implementation, or our subcomponent implementation, and pass it one important thing here. Remember I said that we can depend on our parents? This is how this parent dependency happens. What's important that on the black side, we know nothing about our parent. But where we have nitty-gritty details, we know that we will pass ourselves as a parent to our subcomponent. Same thing here. Locked-in component abstraction defines only the factory method, but the implementation knows that it will be passed as a parent, where we assemble things, the session component implementation. And it will do the same thing when creating its own child. It will pass itself to the subcomponent. Okay. Now let's go back to the problem at hand. If you remember, we still have kind of a problem here. At the balance scope, or now in this case, balance component should create us this account service, which we needed. And we need authorized client, which lives in logged-in component. So let's see how can we now retrieve it with compile time guarantee. And I will show you the code for these three things. So we have our logged-in abstraction, logged-in component abstraction. We have our implementation. This is where our authorized client lives. I've omitted the detail, but the authorized client was initialized with the session token, which was provided when this logged-in component was created. So we know we are the owner. The authorized client lives in our scope. We pass ourselves when we're creating a subcomponent. This is our sort of non-interesting component of customer, which we have to somehow just simply pass through, or like it stands in between us and the one who is interested in us. The important thing is that customer component knows, implementation of customer component knows about its parent and passes itself to its child. And now this is the key thing here. This is where the magic happens. Given that we know all our parents, at the balance component in the balance component implementation, we can traverse through our parent tree, find this authorized client, and resolve the account service with this authorized client. And this is quite similar to things that the Dagger2 framework does when it analyzes your graph and generates the code for you. But in our case, well, there is no one for us to generate this. And if you're writing your own implementation, you can use these techniques. So if you're not clear on the details, let's see what happened on the graph. What we did is that the balance knows that it wants accounts it wants account service. It asks the component for this account service. The balance component, being implemented by the balance component implementation, starts to resolve it. And to resolve it, it traverses up the tree, finds the component or the scope where this authorized client lives, acquires it, acquires it, and resolves the account service for us. So this was the idea of how you can do things manually. So what we learned here? We learned that the deep scopes can be incredibly useful, especially in interactive applications, because they can decouple your use case and view hierarchy and allow you to avoid a lot of stale state. You keep only things you need, and you deallocate the things you don't need by having this deep scope hierarchy, not the shallow one, where you keep a lot of things at the global scope, a global state. We learned that component abstraction can be terrifically useful for hiding the implementation details of resolving our dependencies, but giving us some kind of a facade where to ask dependencies from. We've seen how segregated composition might be really useful in keeping your modules clean and unknowing about the nitty-gritty implementation details. And if you want a good analogy, think of your own apartment building, if you live in an apartment building where you have flats. So most of those buildings have on the ground floor or beneath the ground floor some kind of closets or something like this, where you can store things which you don't need in your flat. So usually when you go to this closet, you would observe that this ground floor, it doesn't hide any kind of pipes and wirings, etc. And you can think of this composition root and assembly place as of this place where these nitty-gritty details of how the things were put together exist and live. You don't have pipes, hopefully you don't have pipes and wirings running through your flat. You don't want to know about them. You just want water and electricity. Same kind of principle is here. Component abstraction, your facet, your power outlet, the segregated the place in the segregated composition where your implementations live. These are the wirings. And we learned that the dependency graph traversal is tremendously useful for acquiring dependencies from our parent scopes. So this would be it from my side. If you have any questions based on the first part, on the second part, ask them freely.
Looks like you made it all so clear.
or vice versa. Absolutely not clear. What was it about?
Questions, any?
So I totally agree with you. You have to understand the scope, where your object lives when it dies, and that kind of things. But what it seems to me that writing or doing it yourself, you end up with a boilerplate which will transform into your own homebrewed framework, which will be similar to Dagger, similar to Spring, similar to any CDI or whatsoever. So it's just you do it yourself. What's the point?
Terrific comment, actually. You're absolutely right. We've been thinking now how we can sort of generate this code for these implementations. It's definitely can be generated. Whether it's worth an effort or not, it's questionable. The point here is that, well, Dagger is available for Java, but it's not available for Swift, Rust, Go, Dart. There are no such complex frameworks in certain languages. Well, if you don't have them, but you want all the benefits of this, you have to do it your own. And it's really useful to know how to roll your own, how it works, because it will allow you to understand better how the frameworks work. And in case you have no frameworks or you want to quickly prototype, you could go only to a certain extent. I could have not implemented, for example, this deep scope hierarchy. I could just have used the first three principles and patterns, and that would be it. Use some global state. Well, trade-offs. But this is the point. Yes. But you're true.
You're jealous to Java, right?
Maybe one from my side is that it's maybe kind of unique to Java that you have great variety of frameworks maybe for those kinds of
Too many.
Yeah, too many. And especially for the new emerging languages such as Golang and Swift, you oftentimes end up building yourself very trivial tools. This is good.
Maybe you should not use this language.
How do you then finally get away from Java?
There are certain
That's
platforms,
the point.
where you simply cannot use anything else, maybe, or it would be really painful to use Java. And moreover, with Java, well, I think nowadays mostly if you're writing Android, then you would use Dagger, and it's fine. But sorry, I will ask you in a second. But as a comment, if you use Spring, for example, Spring doesn't provide you compile time guarantee, and Spring can run into cyclic dependencies and can fail you at runtime. So there is a difference in this case. But there the Spring usually is used. This is not a problem. Okay.
So if main motivation is absence of frameworks in certain languages, why not to form all of these into a framework and start like open source and distributed?
Yeah, as I said, we're kind of, first of all, it wasn't like that obvious. We had this problem. Initially, we solved it with, as you remember, the passing down the dependency. And it's like it works. And we had this problem when we realized and recognized how we can sort of cleverly avoid it by looking into, for example, what the Dagger compiles and examining how actually the Dagger works. And it sort of inspired us to find a way. But taking it to the next level, sort of creating your own library, it's a lot of effort, and you might simply not have enough time for this effort. And there is no like, let's say we're currently only evaluating whether it's worth of our effort to try to do this code generation or not. So maybe.
Guess that was the last question. Vadim, thank you so much.
Next time, I have something to wear.